All right, so we're moving on to lesson 6.3. Here we are going to look at sums and maybe differences also. We'll see if we do any subtracting of radicals. So we haven't done any adding or subtracting with these radicals we've been working on, so that's what today's lesson is all about. So just as a review on how we add and subtract like terms, combining the radicals is going to be pretty similar to this. So here's a 5x. We know that it would go with this minus 2x because those both have an x and they go together. So 5x minus 2x is 3x. Then we can see that we have a positive 3y minus a y. Well, 3y minus 2y, 3y minus y is a positive 2y, and that's our final answer. So we look for any like terms and we put them together. So now that we're talking about radicals, what makes a radical a like term? So it all comes down to the radical itself. In this case, we have square roots. So here is a 5 square root of 2. That means that we have 5 of these square roots of 2. Here we have 3 of these square roots of 3. We're subtracting 2 of these square roots of 2, and then we're subtracting, think of this as they're having a 1 in front, 1 of the square roots of 3. So when we think about like terms, the like terms are going to be the ones that have the same radicals. So there's a 5 square root of 2 minus a 2 square root of 2. So it's that square root of 2 that I'm focusing on. Well, if I have 5 square roots of 2, and I subtract 2 of them, I have 3 square roots of 2. So that square root of 2 stays exactly the same, just like your up above, the x's stayed the same when you combine the x's. So this is going to work the same way. Now we have 3 square roots of 3, that's positive, minus a 1 square root of 3. So how many square roots of 3 do we have? Well, we take our 3 minus our 1, and we get a positive 2 square root of 3. So not too bad, just make sure you understand what the like terms are when you put them together. And then the radical itself does not change, it's just we're adding or subtracting the numbers out front. All right, so let's look at a couple examples. Now, if you thought it was going to be as easy as the one I just talked about, sorry to disappoint you, sometimes it's a little bit more involved. So when we look at our first example, we have a square root of 8 plus 2 times the square root of 2. So these radicals are not like terms. They're not the same, so we can't add those together. However, it's possible that you might be able to reduce a radical. You want to get it in its simplest or lowest terms and then see if you have any like terms. So the square root of 8, because we're talking square roots, you want your squared numbers, 4, 9, 16, 25, that whole list. And remember when we were breaking these down in the other lesson. So what's the biggest number that fits into 8? 4 fits in 2 times. So we basically simplify the square root of 8 to 2 square roots of 2, carry down the rest of the problem, and now look to see if we have any like terms. And we say, oh yeah, now we have square roots of 2, so we can add those together. So the square root of 2 stays the same. How many do we have? We have 2 of them plus another 2 of them, so we have 4 square roots of 2. So these problems aren't that bad. You just might have to reduce some radicals before you combine like terms. All right, example 2, bunch of square roots again. I can see that none of them are the same, so let's get them all into simplest form. Square root of 3 is already reduced. We can't do anything else with that. Square root of 27, we can break that down. So think about your numbers, 4, 9, 16, 25. Well, 9 fits in 3 times. Square root of 9 is 3, square root of 3, so that got reduced. Now the square root of 300, I want to talk about that for a minute because, you know, you go through your list, 4, 9, 16, 25, and you might say, oh yeah, 25 fits in. Well, 25 fits in 12 times because 25 times 12 is 30. Well, remember what we've been talking about is how do you know if this is the biggest square root that fits in? Or the biggest squared number that fits in, you look at the other number. Do any squared numbers fit into 12? 4, 9, 16, 25? And you say, well, yeah, 4 fits in. So what that tells you is 25 is not the biggest number. There's a bigger one that exists, so I would take another 10 seconds and figure out what it is. So if you go through your list, 4, 9, 16, 25, 36, 49, 64, 81, 100, there it is, 100. And it might be helpful to, anytime that you have a quiz or homework, just write those numbers across the top because you're going to keep referencing them over and over. So 100 times 3 is 300. So I'm going to bring down the plus. The square root of 100 is 10. Square root of 3. I'm going to bring down the square root of 3 in the beginning of the problem. And now we have like terms. Here we have a 1 square root of 3 plus 3 square roots of 3 plus 10 square roots of 3. So my answer is going to have that square root of 3, and how many do we have? 1 plus 3 is 4, plus 10 is 14. 14 square roots of 3. All right, so next example, I can see that I don't have any like terms, so I want to see if I can reduce these into simplest form. So the first one, 27, what's my perfect square or squared number that fits in? That's going to be a 9 times 3. And see this 2, that 2 is important. We want to remember that that is out in front. Well, the square root of 9 is 3, and it's going to get multiplied with that 2 that was out front. So we actually have a 6 square root of 3. Bring down your plus sign. We can reduce the square root of 12 with a 4 and a 3. So that turns into 2 square roots of 3. And then we have the square root of 7 minus the square root of 75. So 25 fits in 3 times. So minus square root of 25 is 5, square root of 3. So these are all like terms. I know my answer is going to have the square root of 3, and let's just see how many we have. We have 6 plus 2 gives us 8, and 8 minus 5 is 3 square roots of 3.